Hi everyone. Thanks for joining our presentation at Spinnaker.Live today. I'm glad the Spinnaker community is able to get together virtually this year. We hope you've enjoyed the main stage presentations and we hope you enjoy our talks as well. Some quick notes before we begin. If you have any questions, please type them into the chat function and we will answer them throughout the presentation. And if you want to engage with other attendees, you can do so through the portal. After the breakout session concludes, head over to the main channel for games and prizes. On to our presentation now, Designing Deployment Workflows with Spinnaker. My name is Nav and I'm a SRE for the Adobe Experience Platform. Here co-presenting with me today is Pranay, a software engineer also with the Adobe Experience Platform. Today we'll be talking about how you can use Spinnaker to support advanced workflows. I'm going to kick things off with some background for everybody and how we got to using Spinnaker and Kubernetes, and then Pranay is going to take a deeper dive into our Spinnaker pipeline and where we are today. You might be wondering what Adobe Experience Platform even is. Well, Adobe Experience Platform is a purpose-built customer experience management platform that is able to take data from any source and use that data to deliver a more personalized experience when engaging with customers. Here's a quick video to give you an idea.
Target's been neutralized. I'm heading to the hotel. Checking into the penthouse. The name's Hunter.
Certainly, Mr. Hunter. I have your reservation right here.
Wait, did you say Hunter?
Mm-hmm.
No, I don't have a Hunter.
But you emailed the confirmation to my watch.
Well, marketing handles emails. Oh, I have a Hanson.
No, it's Hunter.
Hunter.
I picked my room on your app.
Oh, we have so many apps.
But I'm a platinum member. I even have a promotion from your website.
Promotions are on a different system, but I do have a single on the ground floor, Mr. Hanson.
It's Hunter. My name is Hunter.
So, Adobe Experience Platform is composed of many teams and about 350 microservices. Pranay and I work for the Pipeline team. Pipeline is a geo-distributed real-time streaming platform developed globally in a mix of Azure, AWS, and Adobe data centers. You can think of Pipeline as an API-first design that utilizes Kafka under the hood. We're currently deployed to 15 data centers, which are all interconnected, and there's about 115 applications or services which utilize Pipeline, and that number is growing every day. We're processing approximately 110 billion messages a day with 30% year-over-year growth. Most of the real-time data on AEP is processed through Pipeline. Over time, it's come to be the data foundation, not just for AEP, but also for the Adobe Experience Cloud, which consists of Adobe's other digital marketing products. Today, we'll be talking about our team's experience with Spinnaker and how our Spinnaker pipelines work for the Pipeline team. We began using Spinnaker about a year and a half ago, and since then, we feel like we've gotten a great deal of value by using Spinnaker. So let's talk about where we were before Spinnaker and Kubernetes came into our lives. Prior to adopting them, we had a geo-distributed Kafka clusters that consisted of cloud VMs and bare metal hosts. On top of Kafka, we had a suite of microservices that provided produce APIs, consume APIs, VMmakers, and other enhancements we built to provide a better experience for our internal clients, which were, for the most part, other teams at Adobe, though we do have some external clients as well. Because some of the microservices required super low latency connectivity to the Kafka clusters, we had to run those microservices on these VMs and bare metal hosts, which required building and shipping RPMs of the microservices to these environments. Then we would update and run our source code, which would deliver these new builds to the VMs and bare metal hosts. Over time, we migrated our APIs and microservices to Mesosphere's DCOS, Data Center Operating System, which is managed by another team at Adobe. While there were many great things about this offering, such as handling DNS, load balancing, security compliance, logging infrastructure, and many other things, it did have some limitations, namely with the CI/CD tooling. It came with the internal CI/CD tool, which required a certain approach, and we felt that approach was not the right one for what we wanted to do with a CI/CD pipeline. Another issue we had was this DCOS wasn't available in all the locations where our Kafka clusters were. So we were kind of stuck in the middle, running our services on DCOS in some locations and directly on VMs in other locations. With that in mind, we wanted to brainstorm and research a solution that we could use globally in all our data centers that were a mix of, Azure, AWS, and Adobe. This deployment mechanism across had to be consistent, reliable, automated as much as possible, auditable, flexible, and easy to pick up for any new team members or new users. This solution had to support all the services we currently build and run, in addition to reducing our maintenance and deployment overhead of the way we had been doing things, while at the same time, providing as few new overhead as possible. The solution also needed to have auditability configurations, preferably by having them checked into and pulled from Git. When we began this project back in 2018, we were aware that Kubernetes was getting a lot of traction in the industry, so we began to examine Kubernetes as the platform to run our services on top of. Our team was really excited about the features and flexibility Kubernetes offered, and with so many cloud providers offering managed Kubernetes offerings, we knew we could take advantage of that to reduce the overhead of maintaining and supporting Kubernetes clusters ourselves. Some additional benefits offered by Kubernetes that it's open source with a huge community. It works across clouds and bare metal, and adoption is high, which leads to a high availability of tools and integrations. With Kubernetes decided as the platform for our microservices, the next thing we wanted to do was tackle CI and CD. We evaluated both CodeFresh and Spinnaker, and we decided to go with Spinnaker for a few reasons. First, Spinnaker is open source, and while the community isn't as large as Kubernetes, since we started using Spinnaker in 2018, we've seen quite a bit of growth in the number of blogs and websites mentioning Spinnaker, in addition to overall activity growing on the Spinnaker Slack. This leads me to believe, in the last couple of years, the Spinnaker community is also growing at a high rate. So why did we go with Spinnaker? Well, a couple reasons. First, it's designed for and provides native support for Kubernetes. It's battle-tested in high-scale production systems. It was already being used by other teams at Adobe who we could reach out to for their knowledge and expertise on it, and it has a lot of useful integrations. So while Spinnaker can do a lot on its own, the integrations it provides can help achieve even more advanced workflows. Here are the integrations that our team uses that are critical to our success with Spinnaker. Git. The integration with Git allows for files as artifacts in Spinnaker pipelines, and Git can also be used to trigger pipelines. Helm. We have moved to using Helm for all our Kubernetes deployments. Spinnaker can take that tarred up Helm chart, bake the manifest, inject in your environment-specific value files, then deploy that generated manifest. HTTP-based interfaces. This particular Spinnaker integration is very flexible, and our team at Adobe uses it to fetch artifacts primarily stored on Artifactory. That said, you don't have to use Artifactory either. Any HTTP-based artifact can be fetched using this integration. Jenkins, we use Jenkins heavily in conjunction with Spinnaker. Spinnaker can be triggered by Jenkins as well as trigger Jenkins jobs itself, which just opens up a whole lot of options for your deployment pipelines. Pranay will touch more on how we use Jenkins with Spinnaker later when he gets to his part in the talk. And the Kubernetes v2 provider, which is the only provider we use with Spinnaker, and one of the main reasons we chose Spinnaker. In addition, Spinnaker comes in with some built-in notification integrations out of the box. Email, Slack, and Twilio are all available with minimal setup. So when we first started using Spinnaker, this is what our first pipeline looked like. We took a Hello Kubernetes YAML file and set this up within minutes of our Spinnaker becoming available to use. Nothing fancy going on here. Just want to show how quickly you can get set up and running with Spinnaker. Here's our current workflow at a high level. The dev will check in code to Git. Jenkins will see the commit, trigger the Spinnaker pipeline with the configuration parameters. The Spinnaker pipeline will begin. Then it will trigger Jenkins back to start the Helm and Docker image build and push to Artifactory. After the Jenkins job's complete, Spinnaker will use the recently built Helm chart along with environment-specific value files we have stored on Git to generate the final manifest that it needs to deploy to the account or Kubernetes cluster listed on the pipeline. From here, I'm going to hand it over to Pranay to continue the talk as we go deeper into the pipelines.
That was an overview of our updated stack, workflow, and why we needed it. Now we'll go a little deeper into how Spinnaker enables our advanced workflows. Spinnaker is the brains behind our deployment workflows and orchestrates everything after the initial trigger using various different pipelines. Our typical pipeline follows a simple strategy. We start a release by publishing artifacts. These are then used during deployment to the actual cluster. We then run validations against the new deployment. Based on the deployment validation status, the pipeline determines whether to roll back or proceed with the successful release completion. All controls that are passed to the pipeline are done during the execution start or via values files to the Helm chart. We prefer creating somewhat generic pipelines that can be reused by other pipelines and also templatized for other applications. This helps keep things modular and reusable, among other things. As part of CI/CD, the ability to easily roll back during a deploy was a key requirement of ours and something that wasn't trivial in our legacy model. This has become trivial with containerization, the right versioning, and an easy-to-use tool. To avoid having unused resources on the cluster, we created a downstream pipeline that could then clean them up once a deploy or rollback was complete as part of the release. Let's take a look at a demo of our pipelines.
Let's look at a sample app running in multiple environments. In our case, these are dev and stage. I'll attempt to depict the design and strategies that we follow with this walkthrough. You can see it's a simple Hello World app for Kubernetes. Pay attention to the text message. Hello Kubernetes is an open source app that we're using within our own GitHub. We store our Helm-based deployment artifacts within Git. I'm going to make a quick commit to update the message that we just saw. Note that during the remaining walkthrough, I will not interact with any other system other than viewing and displaying it within Spinnaker. I will update the message in Git and commit directly to the branch to trigger a downstream Jenkins job that eventually triggers a Spinnaker pipeline with parameters. For this demo, our auto deploy pipeline has a single stage that triggers a nested Spinnaker pipeline. However, it is easy to add more downstream workflows. As per our strategy, the release pipeline releases artifacts first, a Docker image and a Helm chart in this case, and then proceeds to deploy those to environments. With our actual production apps, the release pipeline can get slightly more involved and include stages to wait between environments or deploy it in parallel if there are multiple regions for the same environment. Our deploy pipeline for a stateless app like this one deploys two manifests. First is for the app setup and readiness, and the second is to switch over traffic using a Kubernetes service resource. The user then validates the deployment if required, and the pipeline determines whether to roll back and clean up the current version resources or to proceed by marking deploy as successful and cleaning up the previous version resources. Let's take a look at how our deploy is doing. Looks like it is just about to do the switchover, so we should be able to go to our dev environment and see if the message actually changed. And voila, looks like it did deploy successfully. If you notice, there are stages that didn't need to run for a pipeline to succeed. This allows flexibility in terms of branching or skipping stages when required. For instance, the dev release didn't wait for me to validate manually before succeeding. You'll notice that the deploy pipeline has restarted after the dev deployment is complete. However, the parameters are different this time since it is executing for the stage environment. Looks like the deployment and switchover is complete, but the pipeline prompts user judgment before proceeding further. This check is useful for higher order environments and can be automated. So let's go to the website and see if the message updated. Our deployment was successful. I will mark it as such in the Spinnaker pipeline. Similar to dev, the pipeline will now proceed with some evaluations to confirm success and then clean up previous version deployments. Notice the template symbol next to Release Artifacts and Clean Up Resources Pipelines, as well as the Pipeline Templates tab in the top nav bar. Templates allow reusing the same pipelines with unique variables across applications, and the ones you see here are actually used in our other applications.
So that was a quick demo of how our pipelines are framed. As we just saw, we have a limited number of pipelines. We use some of these, such as release artifacts, deploy, and cleanup via templates, reducing the maintenance overhead. Consolidation, nesting, and templatizing are important from a maintainability perspective. Through this process, we implemented different deployment strategies for different types of applications, such as stateless, stateful, and jobs. We implemented red-black, which is the same as blue-green, or AB for those not familiar with that terminology, for stateless applications to limit user impact to a minimum. For stateful applications, we implemented a canary-based deployment strategy to preserve app state and didn't require any sort of application cleanup. We started with ad hoc pipelines instead of structured pipelines encompassing all regions and environments, but quickly disabled them to reduce the possibilities of bad consequences in higher order environments. However, over time, we've seen a need for ad hoc deploy pipelines for events such as targeted hotfixes and restarts in a single location in production without having to go through every other environment, preserving valuable time. Of course, these pipelines should have proper safeguards and processes around them. As soon as we had reliable pipelines and structure, we noticed that they've enabled us to easily socialize quick tools within our team. Instead of pointing someone to a code repository with a basic or inadequate README, you can point them to a Spinnaker pipeline where they can run it with a few clicks. So let's look at what we've accomplished so far and compare it to our goals. We've simplified the management of complex workflows significantly compared to our legacy setup with little automation. We now have a consistent process that is more reliable, in large part due to the significant increase in automation. We've been able to do this for multi-cloud and multi-geographical deploys. We've made good on our goal to use configurations as code by storing both application and deployment configuration in Git. This has already resulted in increased auditability and increased reliability of configuration updates since they go through our standard review process. So let's look at some numbers. Here are some numbers in terms of what we've accomplished. Reduced deployment time significantly. For legacy systems, it took 2 resources a day to release one of our key applications in production. With the new CI/CD, it would take a single resource about 30 minutes with parallelization to deploy to a few different geographies. Comparing just the deployment time for containerized services, for DCOS, it took about 2.5 hours for a service with multiple instances deployed sequentially in production. Comparing it with deployments in Kubernetes using Spinnaker, it takes 5 minutes sequentially and even less when we parallelize it. We've also significantly increased the number and frequency of our deploys. Our dev environments are updated on every commit, compared to about once or twice a month as part of the release process previously. Production releases have increased from once a month to once a week for many services, which amounts to about a 3 to 5x increase in production deployments. We also have non-critical services that we release to all environments constantly as there are updates and commits. So that's what we've accomplished. Let's take a look at what's next. We've already covered a couple of different clouds and a few geographical regions in our system. However, we are in the process of increasing our Kubernetes and Spinnaker managed footprint to encompass all regions and services. We started using pipeline templates, but we need to embrace them throughout our applications to avoid the maintenance overhead in managing similar pipelines across various services. Storing our templates in Git would also help socialize them and provide better auditability in addition to Spinnaker history. We want to make releases a non-event by including better testing and validation of a live environment, and proceed all the way through to production with minimal user input for our services. We want to add handling for deployment scenarios by baking them in within the pipeline, such as downtiming relevant alerts. This will help us increase the deploy frequency and improve reliability and confidence in deploys. So that was our presentation on how you can use Spinnaker to design complex workflows. To find out more about Adobe Experience Platform, Pipeline, and our CI/CD practices, please read through our Medium blog series. The first link you see is related to this talk, and the rest go in detail about what Pipeline does. You can reach out to us via email or on LinkedIn. Please enjoy the rest of Spinnaker Live.